Okay, Falcons. Today what I'm going to talk to you about is getting the density of an object through water displacement. So in this example, what I have here is a screw or a bolt. And this bolt obviously is irregularly shaped. So I can't get its volume by measuring its length and its width and its height and multiplying those three numbers to get its volume. I have to find another way to do that. And one method that you can use for that is water displacement. So again, with density, the formula for density is mass over volume, so I'll need those two numbers. So the first thing I would do is take it and record its mass, okay? I've recorded that mass up on the board here for you, 42.94 grams, and then I would need to get its volume through water displacement. So what I've done here is I've measured out predetermined an amount of water. In this case, it's 75 milliliters. Really what I'm looking for is a volume of water that will fully submerge the object that I'm measuring through water displacement, in this case this bolt. After measuring that, and again when I measure that, one thing that's worth mentioning is that I would want to use the meniscus, which is the bottom part of the curve. So I would be looking for the lowest part of the curve, and with my handy dandy eyeball here, I've showed you that you should be at eye level. So if I was measuring this not beforehand, I would get down to eye level and look for the lowest part of the curve, and that's where I'd measure it. This is a graduated cylinder, which has markings to the nearest one, which means I would estimate it to the nearest tenth. So right now it has exactly 75.0 milliliters. When placing this in here, if we were doing this in a lab in class, what I'd instruct you to do is to turn it on an angle as much as you can so that the mass of this, when it hits the bottom, doesn't shatter our graduated cylinders, which is what I'm going to do here now. Then I'm going to turn it again, lower myself to eye level, and measure the volume again. Okay? The volume now is 80.5 milliliters. Okay? So then the question would be, how much volume is the screw itself? The way that I would determine that is by subtracting those two volumes. The volume at the end with the screw minus the volume at the beginning without the screw gives me the volume of the screw itself. Then to calculate the density, I would simply take the mass that I measured divided by the volume that I've now determined through water displacement, and that would give me the density of this particular bolt. This density could then be used, if necessary, to identify the material that this bolt is made out of. In this case, this bolt is made out of, if I was to look at a reference table, this value falls in the range of steel. Steel is actually an alloy, so it can have a range of densities, but those ranges generally are between 7.75 and 8.1 grams per milliliter or grams per cubic centimeter. Remember from earlier videos, a cubic centimeter and a milliliter are equivalent. One's just for liquid and one's for solid volumes. So this would fall within that range, which would allow me to identify this as steel. If it was a higher value, I might determine that it's made out of copper or gold or some other metal rather than steel, which is primarily iron. Thanks, Falcons, and again, this is measuring density through water displacement.